We have the reciprocal of sine, the reciprocal of cosine, and the reciprocal of tangent. Okay, so remember, reciprocal is not the reciprocal of the angle. Okay, reciprocal is the reciprocal of the sides. So the inverse cosecant is the inverse sine of opposite over hypotenuse. So if you have cosecant, the way I do it is I change it to the inverse sine and I flip it, because then it's real easy to see on the unit circle what it is. You don't have to do that, but it makes it easy, and we can do that because the restrictions for inverse cosecant are the same as inverse sine. We can only be in quadrants 1 and 4. And again, we did not graph those, so we can't see what the graphs of those inverses are from Unit 2, but we know that they are in 1 and 4. And if you want me to show you those inverses, I can do that later. Same thing with secant. That is the inverse cosine of adjacent over hypotenuse. So if we were given secant inverse, we could change it to cosine inverse if we flip the side. Hypotenuse adjacent changes to adjacent over hypotenuse, because those quadrants are also 1 and 2, just like cosine. Now, cotangent, it doesn't really benefit you to do that because you still have x over y, y over x. And I don't do it for cotangent because the restrictions are not the same as tangent. Cotangent is in 1 and 2, so it goes with the secant and cosecant. So both reciprocals for sine and cosine go with each other, but the reciprocal for tangent does not go with cotangent. So again, the adjacent over opposite, or if we're on the unit circle, like here, if we're on the unit circle, that would be 1 over y, or just y. If we're on the unit circle, that'd be 1 over x, or just x. Here, this is x over y. Well, y over x doesn't save us any time. X over y, y over x, we still have to do it. It's not like we can just look at the unit circle like we can for the x's and the y's with the x over y or y over x. So again, just be aware, cotangent inverse does not have the same restrictions as its reciprocal inverse tangent. Those are different. The other quadrants are all the same. All right, so we're starting with the calculator part this time. Okay, lots of examples here. Again, remember the directions on this. Whenever you're finding the inverse, the directions have to tell you degrees or radians. Okay, they have to tell you degrees or radians. These say degree. If we have our calculator, we're clearing our calculator on test and quiz day, so you've got to be sure and go to your mode. Since it said degree, that's the only reason we know to go to degree mode. We have to change it to degree mode to answer these questions, because your answer is an angle. If your answer is an angle, there's no way to determine what the answer is unless the directions tell you degrees or radians. You can't look at the problem and figure that out. There's also not an inverse cotangent button on our calculator. So remember, I just talked about cotangent inverse is the same as tangent inverse of the reciprocal. So this would be adjacent over opposite. So this would be opposite over adjacent. It's the reciprocal. Or we can think the reciprocal of 0.523 over 1 is 1 over, well, not equal, the reciprocal, 0.523. So this is what we have to type in our calculator. Now, I don't do the inverse tangent when I'm on the unit circle, but I don't have a choice when I'm using my calculator. So I flip the sides, not the angle. So it's not 1 over the whole thing. It's just the sides that are the reciprocal. So I've already in degree mode. I would hit second tangent of 1 over 0.523. That's how I would enter it in my calculator. Inverse tangent, the reciprocal of the side right there, and that would give me my answer of 62.39 degrees, or 390 degrees. You Need a degree sign on that one. Okay, don't forget your degree sign. All right, inverse secant of negative 2.581. So that would be secant cosine of 1 over 1 divided by, be sure you use the negative sign and not the minus sign, and the negative could go in front of the 1. It doesn't matter. You can make that a fraction. 2.581. Negative 2.581. 112.796 degrees. Again, it is important to practice these. Write down what you're putting in the calculator. If you just write an answer down, when you go to study next week for your quiz or the next week for your test, you're not going to have any idea how you got that answer. Okay, because this is not something that is just kind of given. It's not like you can work your way through it and try to figure it out. These are a little bit more difficult to just know what to push. All right, cosecant, secant sine of 1 over 1.062. 70.325 degrees. It says round to the thousandth. That's what we're doing. The fourth number will tell you if the third number goes up or stays the same. Inverse cosecant of negative 2. So secant sine 1 divided by negative 2, or negative 1 divided by 2, or you can put it in a fraction. Right there, that's one we could do without a calculator. Inverse sine of negative 1/2. We did that yesterday probably. Enter. Negative 30 degrees. So that could have been a problem we could do without a calculator. Very possible. We have a calculator for this particular problem, so we use it. Negative 30 degrees. The direction said degrees, so that's why we're in degrees. All right, this one says radians. Nothing changes. The only thing that changes is our mode. We are still going to do inverse tangent of 1 over 3.557. That's what we're typing in our calculator. And over here, inverse cosine of 1 over 15.268. That's what we type in, not 1 over the whole thing. And inverse sine of 1 over negative 1.056. That's what we type in the calculator. Again, it is a very good idea to write that down because this is not always the easiest to remember when it comes to testing quiz day. All right, so second tangent 1 over 3.557 into 0.274. If you want to put RAD or radians after it, you can, but you don't have to with the radians. Again, if you want to, you can. Inverse cosine, so second cosine of 1 over 15.268. $1.505. And the last one, second sine, inverse sine of 1 over negative 1.056. Negative 1.244. That's 6. Made the 3 go up to a 4. Remember, you're rounding to the thousandth when it says, when appropriate. If it's like an object or a person or an animal, something like that, not appropriate. That's appropriate to truncate. Ignore the decimal. But when we're rounding to the thousandth, that is 3 places. 1 1,000th is a rounding error. More than 1 1,000th is wrong. Are you in the right mode? again, the negative doesn't matter if it's in the front, in the denominator, make it a fraction. Get that down. All right. Always check your mode, because on a test or quiz, you're not going to be able to check to see. You're just going to type it in, press enter, and move on. Always, when you're pressing the sine, cosine, and tangent button, whether it's second sine, it doesn't matter. If you're pressing one of those three buttons, the mode matters. Make sure your mode is correct. Circle it, highlight it, whatever you have to do on a test or quiz, because you don't want to miss that problem because you're in the wrong mode. All right, so that's the calculator. Yesterday we did the sine, cosine, and tangent. There's a button for that. You just plug it in like it is. Not a button for it. You take the reciprocal of the side, okay, not the whole entire expression. All right, now to the non-calculator. This is where we're going to use our unit circle. Give the exact principal value, same directions as yesterday. If your answer is an angle, answer in radians. That has been the direction for all of the non-calculator part. If your answer is an angle, you're going to answer in radians. All right, so the inverse secant of -2. For inverse secant and inverse cosecant, even on the non-calculator, I changed that. I would change that to the inverse cosine of the reciprocal. The reciprocal of -2 is -1/2. Reciprocal, positive is positive, negative is negative. And now that's a problem just like we did yesterday, because secant and cosine both have the same restrictions. We can do that. I don't do that on the non-calculator for cotangent and tangent because they don't have the same restrictions. And if you do that, you might end up in the wrong quadrant. You can, you just have to be aware of your quadrant restrictions for inverse cotangent and inverse tangent. So I'm going to be looking quadrant 2 because that's where x is negative. So my unit circle, I'm looking for where x is equal to -1/2. The reciprocal of that is -2. So the cosecant, or the secant, is -2. The cosine is reciprocal, -1/2. So my answer is 2π/3. Remember, these do not require any work. Your unit circle, you have your unit circle there. That's what you're looking at to get the answer. All right, inverse cotangent. We have our restrictions for cotangent. Cotangent can be in 1 or 2. It is positive, so that means in quadrant 1. So we're looking for where is x divided by y equal to √3. That's what we're looking for. This right here, since we're on the unit circle, is x divided by y. So remember, our two options for a √3 are right here and right here. X divided by y. So √3/2, I can't divide fractions, so I multiply by the reciprocal, cancel those two, and there I have my answer. You do not have to write that down. I'm just writing it down so you see where it comes from. So √3/1 does equal √3. So we found where x divided by y equals √3, and that was at π/6. So there's your answer, π/6. Remember, there are not two answers to any of these. Do not ever write two answers. The most common mistake is when it's 0 and 2π, you think those are the same. They're not the same. They're coterminal. Okay, same, not equal. They're coterminal. We have restrictions. 2π would never be an answer. We can't go into or through quadrant 3, so 2π is not even a possibility at all when we're finding principal values. All right, inverse cosecant. I'm going to change that to the inverse sine of the reciprocal. -1/√2 is the same as -√2/2. Talked about that yesterday. Big, huge slide all by itself. On our notes from yesterday, you have to know, you don't have to rationalize, but you have to recognize what's rationalized, what's not. -1/√2, I don't use that on my unit circle, but I do use √2/2. So I have my restrictions for inverse sine, or 1 and 2, or inverse cosecant. They're the same. That's why I change it. You don't have to. You can look at your unit circle and flip them. So we want to look where it's negative. That's going to be y is negative in quadrant 4, or 1/y is still negative in quadrant 4. So we're looking for where is the y value equal to negative root 2 over 2. That's right there. Not at 7 pi over 4. We cannot go through quadrant 3. We have to go from 0 in a negative direction and get negative pi over 4. Yes. These are the same. Yep. And that's just from your notes yesterday, or from algebra 2. Maybe a little geometry. Precal, all kinds of stuff. Rationalize, unrationalize. I don't care what you do, but you have to know that they're the same because you don't know how it'll be written. All right, cotangent 1 and 2. We're looking for where is x over y equal to negative 1. That is not going to be on a quadrantal. X divided by y. Every quadrantal is an x and a y. There's a 1 and a 0 or a negative 1 and a 0 at all those, so those are off limits. It is in a quadrant. Where are the x and the y the same with opposite signs? That's going to be in quadrant 2. Right over here, where are they the same with opposite signs? At 3 pi over 4. That is your only answer. There are never, ever multiple answers on principal value questions. Ever. Ever. Do not ever, ever write two different answers. Okay, there's only one answer. If you write two, it is automatically wrong. There are not two answers. Only one possible answer. All right, here's our double ones. We have a decimal, so a decimal must mean we use a calculator, but that is not true. We have these ratios. Our SOHCAHTOA, those are ratios. Well, is there any way to make 0.4 a ratio? 4/10 or negative. Negative 4/10. We can simplify that to negative 2/5. That easy. 4/10. If we say it right, 4/10. 0.4 is what we usually say, but 0.4 doesn't give us the math words. So 4/10 is how you write the decimal as a fraction, going back to middle school now, and then reduce that. If you reduce it or not, it doesn't matter. I would reduce because it just makes the numbers more manageable instead of having really big numbers. You have smaller numbers to square and square root, but either way. All right, so this inside. This is a unit 3 problem. So the inverse cosine of negative 2 over 5. Now, look at that to start with. Is that even possible? Is the adjacent over hypotenuse possible? It is. Adjacent to, or negative 2, because the hypotenuse can never be negative, and the hypotenuse is 5. That's a possibility. If it wasn't a possibility, we'd be done, undefined, if those were flip-flopped, because the hypotenuse can't be smaller than a side. So we're looking for an angle in the correct quadrant. 1 or 2 are our choices. Because it's negative, we draw our angle in quadrant 2, and remember our angle is always attached to the origin and the x-axis. Cosine is adjacent over hypotenuse. So now we need the cosecant of that angle. Well, the cosecant of an angle is hypotenuse over opposite. We're not doing inverse cosecant, so we just do regular cosecant. You can change that to the sine of that angle is opposite over hypotenuse, but then that won't be the right answer. I've only switched them when I'm doing inverses, okay? Because I can flip those. Now, if you flip them, you're going to get the wrong answer. It's going to be flip-flop. So no switching when it's just regular sine, cosine, tangent, secant, cosecant, cotangent. That's only for inverses. I never said that a long time ago. I just said that for inverses. All right, so we have the hypotenuse. We need the opposite. So negative 2 squared is 4 plus whatever that, I'm going to call that y squared, equals 5 squared is 25. Y squared is 21. Positive root 21. Root 21. There's your answer. Only possible answer. There are not multiple answers for that. Okay, and remember, we get y equals plus or minus root 21 because we're in quadrant 2 and that was going up. That's why we picked the positive one. Very important you pick the correct one. Sometimes it's positive, sometimes it's negative. Depends where you are. If you have that triangle drawn, it is easy to figure that out. If you don't have that triangle drawn, maybe you get it right, maybe you don't. Who knows? So you label everything correctly. All right, inside part. This is back to unit 1. 1/2 times the tangent of 3 pi over 4. Tangent of 3 pi over 4. We go to 3 pi over 4. Tangent is y over x. So that's equal to negative 1. 1/2 times negative 1, negative 1/2. So this inside part is now negative 1/2. Now we're back to 3.1, exactly what we did yesterday. We did that problem a second ago on our calculator. Okay, so inverse sine can be in 1 or 4. It's negative, so we're looking for where is y equal to negative 1/2 in either quadrants 1 or 4. We hopefully know we are supposed to go to 4. That's all we have to worry about because that's where y is negative. So we go to your unit circle. We look for where is y equal to negative 1/2, not 11 pi over 6, because that takes us through quadrant 3. Negative pi over 6. Negative pi over 6 is the only answer. There are not multiple answers. All right, secant of 5 pi over 4. Sydney? No, I wanted you to put it. All right, so secant of 5 pi over 4. We go to 5 pi over 4, and we look at what is the secant of that. Secant is going to be 1 over x, which is the reciprocal. So 5 pi over 4, that takes us to quadrant 3, and 3 is off limits. 4 inverses. Secant of 5 pi over 4 is not an inverse. That's unit 1. There was no such thing as restrictions. Never even said that word in unit 1. So it's okay. So we go to 5 pi over 4. Secant is the reciprocal of cosine. So 1 over negative root 2 over 2, or we can just take the reciprocal. So that's going to be equal to negative 2 over root 2. So the cosecant, negative 2 over root 2. Now, could we see that rationalized? If you want to rationalize it, you can. Maybe you see it that way. Negative 2 over root 2 over 2 cancels. Negative root 2 is the same thing. Either way, you could see it written. I don't care if you rationalize or not. It doesn't matter if you have negative 2 over root 2 in that parenthesis or negative root 2. It is equivalent. You have to know that it is equivalent. But now that it's an inverse cosecant, I'm going to make that an inverse sine and make that negative root 2 over 2. Because our restrictions are the same, we can be in 1 or 4. We're either looking for where is 1 over y equal to negative root 2 over 2, or where is y equal to negative root 2 over 2. So you go to your unit circle. Here is y equal to negative root 2 over 2, not 7 pi over 4. We have to go in the negative direction because we cannot go through quadrant 3 when we're talking about inverses because we have principal value and we have restrictions. So your answer would be negative pi over 4. Only possible answer right there. All right, another double one. So inverse tangent of 5. Okay, well 5's not on our unit circle, so maybe it's undefined or maybe we have to draw a triangle. Inverse tangent of 5 is going to give us some angle, And remember, that's the inverse tangent of opposite over adjacent is going to equal some angle. Well, opposite and adjacent can be anything. So 5 is okay. 5 as a fraction is 5 over 1. So I need to draw a triangle in the correct quadrant. 2 and 3 are out. It is positive. Positive means I'm in quadrant 1. Opposite over adjacent has to be positive. Positive in quadrant 1, negative in quadrant 4. So opposite is 5, adjacent is 1. How do I know that's 1? Because 5 equals 5 over 1. I need a ratio. I can make any number in the world a ratio. Put it over 1. 5 divided by 1, now it's a fraction. And then 1 squared plus 5 squared equals c squared, r squared, whatever you want to use. So 1 plus 25 equals c squared. 26 equals c squared. So that is the square root of 26. Because remember, we were just trying to get that angle. The cosine of this angle right here that was created is equal to adjacent over hypotenuse, because I'm not on the unit circle. None of those numbers were on the unit circle, so I have to go back to my SOHCAHTOA. So I look at that angle. Adjacent is 1, hypotenuse is root 26. If you want to rationalize it, you can. Root 26 over 26 would be the rationalized version of that. And the last one. So again, that inverse is on the inside. 12 and 13. We should be able to recognize right away that there's no 12s and 13s on our unit circle. So we need to draw a triangle. 2 and 3 are out. We are down in quadrant 4. So we've got our angle. So we're taking the secant of that angle. The secant is hypotenuse over adjacent. So we label what we know. This is opposite over hypotenuse. So we know our hypotenuse is 13. Hypotenuse can never be negative. So this is 12. If you know your triples, you can just write it down. If you don't know your triples, you got some multiplying and subtracting to do. 169 minus 144, 25, square root of 25 is 5. Nope. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so the secant is hypotenuse over adjacent. All right, so now we have all of our sides. So the secant of that angle is the hypotenuse over adjacent.